I wasn't sure if I needed to fill you in on my testimony, but if you were here, my parents and I shared about our journey, and even though much of what we talk on is on sexuality, our testimony really, though it touches on sexuality, isn't just about only sexuality. It's about a lot of other things. I mean, I hope the one thing that you took away is that we all need Jesus. Not, those people out there, but we all need Jesus. And so my journey, yes, touches on all these things that oftentimes Chinese we don't talk about, whether it's drugs or promiscuity, and I don't want to give the impression that somehow all gays and lesbians do that. Unfortunately, that's just part of my story. But at the end of the day, we all are sinners, and we all do, because of our sin, we need someone to help us, and that's Jesus. So this morning, I wanted to talk a little bit more and delve into the issue of sexuality. There's going to be a lot of notes, so if you would like to jot down the short URL, or you can scan this QR code. If you don't know what a QR code is, that's a page. Just write down the short URL, and that's going to be a little hard to draw on your paper. But my notes are online. Like I said, there is a lot of information as I look into this issue of sexuality, and more importantly, what are some of the possible causes or factors that plays into the development of sexuality? A lot of times people say, well, we already know what is the answer. On one side, people say, people are born gay. It is genetic. The other side, people say, no, it's a choice, and people can change. And I think that when we look, both are not as accurate as I think, or when we make such broad statements, sometimes those statements are more simplistic than anything else. On one end, people say, people are born gay, it is biological, it is genetic, and so therefore it's not immoral. On the other side, people say, well, it's how one was raised, or it is a choice, and so therefore people can stop being gay. And I think that both of those base their premises upon this, what we find the result of, whether it's nature or nurture. So I want us to look at some of the research that touches on the possible causes of homosexuality. If you remember, before I became a Christian, went to dental school, and so I studied pre-med in college, and then while in dental school, I actually was like 5 years in dental school, but never got my doctorate. So unfortunately, with all the schooling that I had, I actually went into dental school without getting my bachelor's degree, because I thought, well, I'm going to get my doctorate when I get a bachelor's. But unfortunately, I never got my doctorate, so I ended up with a lot of hours of schooling, graduate and undergrad, a lot of debt, and no degree to show for it. No bachelor's, no associates, no master's, no doctorate. So as Chinese, oftentimes we think, wow, that's such a waste. Are you ever going to go back and get your doctorate? Well, my father's a dentist, my brother's a dentist. We have teeth covered in our family. I don't really, think I need to do that. And besides, I really love what I'm doing. However, it's neat to see that didn't go to waste. Because with this knowledge of the science and statistics, I'm able to apply that to the ministry that we're in today, my parents and I, on the issue of sexuality, where I can look at some of this research and the science and the statistics and be able to understand it. Because honestly, in seminary, they don't teach you much statistics and science and math in seminary. I mean, being Asian, that definitely helps. So anyway, it's neat to see how God redeems our past. Doesn't He do that? He takes our past and He redeems it, whatever it might be. So we want to look at some of the science, the research, but also I thought it would be important then to look at this through the lens of Scripture. I think we always need to take it back to the Word of God and see if what we understand to be true, well then that will line up with the Word of God. So we will look at this morning the etiology of homosexuality. What is the etiology of homosexuality? Well, etiology is what many of you guys know. It's the study of causation. Sometimes this is used in the sense of studying the causation of diseases. I do not view sexuality as a disease or homosexuality as a disease. I strictly take this etiology as a term for just what are possible, the study of causation. So I'm breaking it down, the research, into two groups. First group is studies that focus on biology, whether it's genetic, whether it's hormonal, whether it's neurological. There's a bunch of research that has been done. So first of all, one of the first studies that focused on biology was twins. And of course, researchers, they studied twins, specifically identical twins, and they compared to fraternal twins because identical twins share identical genes. Fraternal twins share maybe up to 50% of the same genetic material. So they would compare. They want to see if there's any type of genetic link to any factor or any trait. Well, they would study twins. Bailey and Pollard in 1991 did a study. And in his study, he had an applicant pool, and he kind of researched some twins that were both identical and some that were fraternal, some that were gay, some that were not gay. And he found that 52% of his applicant group showed that both were gay. Fraternal twins were not as high, 52%. It was about 22%. But we need to see that it's not 100%, which would, if it was 100% or at least close to 100%, such as 90s, maybe 95% or higher, then it would point to that this is a genetic trait. So, for example, hair color or eye color, and we see that is a genetic trait. When we say something is a genetic trait, that's saying that it's 100% a genetic trait. But as we see from this study, not all twins were gay, not all identical twins were gay. In addition, Bailey and Pollard, when they did this study, there was a big fault in it, a big weakness. And that was, in this study, they did not, it was not representative of the general population. When they advertised for this study, they advertised strictly in gay magazines. And they advertised strictly in Chicago, in the gay neighborhood. So, of course, you're going to get more people to participate in the study and probably skew the results, and this would not be representative of general sampling. So this percentage would be higher than normal. So Bailey realized that with this, and so he tried to do the study again. He went to Australia. Bailey, Dunn, Martin, I'm not too sure what happened to Pollard. Maybe he fired him. So in 2000, he did a study in Australia, and what he found wasn't 52%, but it was 30% of identical twins. So not as high, but still 30% I think is fairly high, more than normal. What's the percentage that we often assume the percentage of people who are gay? Yeah, I mean, right now it's around 5 or maybe 3 to 5%. But what was the number that like 10 years ago when people were asked, what's the percentage of people who are gay? 10%. I mean, usually some people just assume 10%, but that was done by some research by Kinsey that has been found to be not accurate to represent general sampling, especially because he was researching men in prison. And I can tell you men in prison do things that they don't normally do when they're not in prison. But anyway, 10% is not really accurate. It's more closer to 3 to 5%. So let's just say 5%. Well, 5% compared to 30%, that's higher than normal. But people were not able to replicate this study. As many of you know, when you do research, you could come to some, to have some findings. Well, to show that your findings are accurate, someone else needs to do a very similar research and then come up with very similar findings, and then that would, in a sense, confirm the two studies. So no one has been able to replicate this study. Actually, Bierman and Bruckner in 2002 did this study, and they found 6.7% when one identical twin was gay, the other one was a gay. In Sweden, another study was done in 2008, Lundström, Raumann, Karlström, and Lichting. And this was actually the largest twin study test done in history. And they found they were not looking for concordance rate. Concordance rate is when one twin is gay, what's the percentage that the other twin is gay as well. And they found that among men, they believe genetics played maybe 34 to 39%, shared environment played 0%, individual-specific environment played 61 to 66%. And what is shared environment? What is individual-specific environment? Well, shared environment is environmental influences that cause siblings to be more similar to one another. Non-shared environment are environmental influences that cause family members to differ from one another. And this is one distinction. When you read these studies, when you hear the word environment, oftentimes we think of non-biological factors. And this is where it gets a little bit confusing. In some of these studies, researchers are including in environmental factors some things that I would kind of put in the category of biology. So for example, in this study, the researchers, they considered the hormonal differences in the womb when you have two twins, because researchers believe so. So for example, if twins, if they share the same placenta, or if they share the same amniotic sac, then they could get different hormones. So in this research, they put hormones in the category of environment because they thought, well, it's not genetic. If it was me, I would have tried to kind of tease it out because genetics is part of the kind of broader category of biology. But environment, I think, is more sociological, psychological, developmental, those type of issues. But anyway, regardless, they believed that genetics was not the only factor that played into the development of sexuality. For women, they believed that genetics played much less of a factor in the development of sexuality. They believed that it was 18 to 19%, so much less. Shared environment was maybe 16 to 17%, but the majority was individual-specific environment that played into the development of sexuality. So at least from their study, they believe that environment does play a role, and specifically for both men and women. If you see, they also showed that individual-specific environment played a large role. This is what they had to say, though, about the results. Although wide confidence intervals suggest cautious interpretation, the results are consistent with moderate, primarily genetic, familial effects, and moderate to large effects of the non-shared environment. And so again, remember, for them, non-shared environment is the sociological and also psychological and also biological, such as hormonal, same-sex sexual behavior. So, they're making a statement and saying that the confidence interval is really, really wide, and so there should be cautious interpretation. Well, what does confidence interval mean? If you took statistics, that would be a term that you're familiar with, but for maybe the rest of us that aren't familiar with statistics, confidence interval is basically, it depends. You can have a 90% confidence interval or 95% confidence interval. So this is actually 95, the number that I'm going to give you in just a moment is 95% confidence interval. And so that means when you take 95% of all the kind of results that they have, they all fall between this range. So obviously, as a statistician, you want your confidence interval to be narrow, right? I mean, if you find something just between, like 10% or something, that would be, you would really find something very significant. But if you have results that kind of span between 60%, what do you think that really means? Not that much. I mean, because when you have something that's so wide as 60%, and you have just results falling all between that 60%, 95% of that, that's not necessarily very significant. I mean, it can be significant for something else, but when you're trying to find results of this, because what they're really pointing to here is this is more of a median range as opposed to really an accurate result. Because when you have more of a confined and narrow confidence interval and you do a mean, well, that's the mean then more represents what could be possibly true. So how wide are these confidence intervals? Well, actually, another example, I try to make something more understandable. It's kind of like a margin of error. I mean, margin of error is not the same thing as confidence interval. But margin of error, you also want that to be narrow. As we read polls, like presidential polls, and if you read in a fine line, there's always, it says margin of error plus or minus however many percent. Oftentimes it's plus or minus 3%. That's pretty normal. But if you read something that said plus or minus 20%, what do you think about that study? Not very accurate. Not very accurate. So you always want the confidence interval to be narrow. So let's look at how wide this confidence interval is. 95% confidence interval. Genetics, 0 to 59%. That's basically, 60%. You're finding all the scattering of all the data, just all within 60%. Shared environment, not much better. 0 to 46%. Individual specific environment, 41 to 85%. That's enormous. That's a huge confidence interval. And so, it's actually not that, when you have such a wide confidence interval, you're just kind of making a lot of speculation. But I was interested in what was the concordance rate. When one twin was gay, the other twin was gay as well. They didn't publish this. They were just looking at, what were some of the possible causative factors. And I wanted to be able to look at the concordance rate so I could compare it with the other studies, because that's what the other studies were looking at. They didn't publish it, so I kind of had to do my own math. I had to read through the data. And I found that there were 71 pairs of identical twins. MZ stands for monozygote. So there's 71 pairs of identical twins, and only 7 of them expressed that they had a same-sex sexual partner, compared to 26 out of 214 identical twins. So it's about 10% of men and 12% of female identical twins that both were gay, according to this study. And I want us to note something that I think is fairly significant, is that they actually, in their study, they weren't looking for people who were necessarily gay. They asked a question about whether they had a same-sex partner. And there's a reason for this, and I think it's a legitimate reason. In the other studies, what was done was that they were advertising this study as they were recruiting participants and saying, this is a study on genetics and twins and sexuality. So when people get that notice and they say, this is a study on twins and sexuality, that automatically can cause a little bit of change in the data. That can, what we call response bias, or people who are participating in that study bias, because then automatically they know what the study is for, and they will either opt in or opt out because of their interest or disinterest in the study. And so that can cause inaccuracy in the data. So Langstrom realized that, so instead of advertising and saying that this is a study on twins and sexuality, he just said this is a study on twins. He just left out the sexuality part because he wanted to make sure that the data was as accurate as possible. And as the twins were filling out the questionnaire, they didn't ask, are you gay? Because again, they were afraid that if they asked that, then it would be really apparent what the study was for. So they had a whole bunch of questions, and they asked some questions about their sexual practices. And among those questions, they asked, have you ever had a same-sex partner? So I think it's good that they were trying to do their best to make it as unbiased as possible. The downside of that is there's some vagueness about whether these people were actually gay or not. Because just because you have a same-sex partner doesn't make you automatically gay. You could be experimenting, you could be bisexual. So actually these numbers, I think, could be a little bit higher than normal. However, I do believe that among the rest of the studies, this study does represent some of the more accurate research so far. But overall, in conclusion, as we look at all the twin studies, we show that it's not just genetics. That there's other factors that play into it. Some that are environmental, some other biological factors. And we also need to realize that identical genes don't behave identically. This is some of the, what researchers are finding out more and more, that just because you have this, we have some gene, doesn't mean that that gene is going to get expressed. We have a lot of genes that we have that aren't being expressed. And what doctors are realizing now is that we could have some gene that's laying dormant for most of our life, and then later in life, all of a sudden that gene gets expressed. And doctors are trying to figure out why is that. And oftentimes, doctors are kind of coming to the conclusion is that there's this complex interplay between genes and environment. That somehow environment does have some type of influence with our genes. How that all plays out, we don't exactly know, but we do see that there is this complex interplay between environment and genetics. So just because we have a gene doesn't mean that it's necessarily going to express or that it is going to behave identically either, because it does depend upon our environment. So twin studies, that's one group of studies. Another group of studies is looking at the brain. Simon LeVay, in 1991, did a study on the brain, specifically the hypothalamus, because the hypothalamus is believed to be the regulation for sexual behavior in animals. LeVay studied cadavers, and specifically was looking at the hypothalamus. And he studied 41 cadavers, 19 of them that were gay, and the majority of them, and they all died of AIDS. 16 were heterosexual, and I put here in parentheses presumed, because the only reason that LeVay put them into the category of heterosexual was because that before they died, they weren't open about their sexuality, or it wasn't on their records that they were gay. And it's, it's a little bit difficult to ask a cadaver whether they're gay or not, as they're dissecting them. So I put in here just presumed. We don't know for sure whether they're heterosexual or not. And then down here we have 6 presumed heterosexual women. 1 died of AIDS. So LeVay was looking at the different neuron groups in the hypothalamus, the INAH1, 2, 3, and 4. And he found that in the INAH3 group, that it appeared twice as big in the presumed heterosexual male group than the gay male group. Some other researchers tried to do the same study in 2001. They could not replicate this study. They did not find any statistical significance when comparing the size of the INAH group of the hypothalamus in the heterosexual male group than the homosexual male group. LeVay had this to say about his study. And he said, "It's important to stress what I did not find. I didn't prove that homosexuality is genetic, or find a genetic cause for being gay. I did not show that gay men are born that way, the most common mistake people make in interpreting my work. Nor did I locate a gay center in the brain." And this is important. "Since I look at adult brains, we don't know if the differences I found were there at birth or if they appeared later." So another group of studies is looking at the chromosome. Specifically, Hammer, Hu, Magnuson, Hu, and Petitucci, so a bunch of Chinese were involved in this one, studied 76 gay brothers and their families. And what they found was pretty interesting. Among these gay brothers and their families, they found that on the mother's side of the family, there appeared to be more homosexuality than the father's side. So therefore, they studied the X chromosome. Because of course in men, we have the X and the Y chromosome. We get the X chromosome from our mother, the Y chromosome from our father. So Hammer studied the X chromosome in gay men. And he found that in 83% of gay men, there was a portion of the X chromosome that was similar across the board among 83% of those, of the participants. This finding, as when it was published, was popularly but inaccurately dubbed the gay gene. How many of you guys remember that? You guys remember that? In 1993, yeah, it was on the cover of Time magazine, and it was called, I think even they said on the cover, "We found the gay gene." Well, this is what Dean Hammer had to say about this, who is gay. He said, "Environmental factors play a role. There is not a single master gene that makes people gay. I don't think we will ever be able to predict who will be gay." And I think this is very important. When I teach in the college setting, I always tell my students, go to the sources. Whenever you're reading something and you find something very interesting, if you can, try to go back to the primary source. Because unfortunately what happens in secondary or tertiary sources, what happens? They don't, they twist it. For example, in Time magazine, well, generally, I mean, when people report, even in the New York Times or, you know, other reputable, you know, what are some other reputable, I'm trying to even think of the reputable, I mean, we can debate on even New York Times, but, you know, the more reputable types of magazine articles, news, you know, even the television, people who are the reporters, what do they study in college? Journalism, communication, English. They probably failed out of science, you know, and yet they're the ones reporting these things. So I mean, they're probably, they don't know what they're even reading, and so and yet oftentimes we just take their word for it. We're like, well, they said it on CNN. Well, who wrote that? You know, an English major, not someone who knows science well. So they, unfortunately, news gets a lot of this data wrong, and they misreport on information. So I think it's important for us to recognize those things. So go, you know, whatever we can, always go back to the source. Cameron himself said that there's not a single master gene. He believes that there's not a single master gene that makes people gay. I don't think we'll ever be able to predict who will be gay. He didn't also have a control group. I think that was important. You know, whenever you do research, you want to have a control group. Like if you're studying medicine, if you're studying some type of new drug, you want to have a control group, a group that either takes a placebo or they take some other medication that has known results and compare that. They didn't do that. You know, the control group would have been if he studied gay men, he would study straight men. Because if he did that, and he didn't do that, but if he did do that, then what happens if he found that, you know, among gay men and straight men, that they all do share this similar X chromosome? What did he find? That men are similar. I could have told him that. He could have saved a lot of money. So anyway, there was no control group, but you know, we don't know. I think some people just recently are doing a similar study to that, and that hasn't been published yet. I mean, we're talking about like just this month or next month it's going to be published, so I'm interested to see the results of that. Bailey, same as Bailey Pollard, Bailey Dunn Martin, who did the study on twins. He also tried to do this study in 1999, could not replicate, did not find any similarity in X chromosome among gay men. Nigel Malcolm in 2000 also did a similar study, and they could not replicate it. So there's actually a lot more studies out there, even some recent research, and I wanted to kind of point to some of these that have been quoted the most. But there's some more recent ones, but honestly, we have not come up with any conclusive evidence to say that this is the cause or this is the cause. There's actually more questions than there are answers. So let's move on to the studies that focus on the environment. So biology would be looking at genetics or hormones or neurological prenatal environment. So environment would be more sociological, familial, cultural, developmental. So what are some studies that could point to that it could be environmental? Well, twin studies, such as the one done in Sweden. They believe that environment does play a factor. And of course, they believe that the hormonal, kind of prenatal hormonal environment plays a role. They would put that in the environment as well. But you know, they didn't split that up, and so you know, I don't think that he believes that when he's talking about environment, he's talking about just strictly prenatal, but that could include other sociological, environmental effects as well. So that's one. I think that points to that it could be possibly environment. Another bunch of studies are on familial. Christians often will say, well, it's because of parenting that is. And then people who kind of speak against that say, well, there isn't any research on that. There is some, but unfortunately, many of this research is very, very old. You know, from generally speaking, I mean, when you look past the 1990s, which is all of these, researchers don't really count that research in. Just like if you guys are doing research in, you know, whatever, engineering or you know, chemistry, the older research, you don't really. It doesn't have as much weight. Why is that? Because I mean, we found a lot. You know, every 10 years, we find more new findings, and so it's better to go to the newer research. In addition, many of these older studies don't have the same expectation for accuracy or peer review, etc. So even though there is some here, I think we shouldn't put as much weight on them. I do find it interesting, though, as we look at these, all these different names. We had the Jonas Brothers up here in 1944. We have Justin Bieber here in 1962. Who knew? Some other studies: Kendler, Thornton, Gilman, and Kessler in 2000. They studied American twins, and they believe that familial factors could have an influence. This is also very interesting. Taiwan did a study in the military. Lung and Shu in 2007 studied 275 men in the Taiwanese military, and they believe that paternal protection and maternal care could possibly play into the development of sexuality. Other studies have been done. Childhood gender nonconformity. This is when a boy kind of doesn't fit in with the other boys and doesn't like to play with the trucks and the balls, but maybe likes to play with dolls and with lace and stuff like that. That's called gender nonconformity. Fraternal birth order has also been studied, where it's believed that as boys, as they get further down away from being the firstborn, there's a higher percentage that child could become gay or experience same-sex attraction. That's another study. But again, nothing has been fully conclusive. Other studies have been looking at maybe comparing urban versus rural, etc. Now, as I presented the biological studies, I kind of critiqued them, and I didn't really critique these studies. So I want to do that now as I look, and especially I want to critique the familial factors. Is it parenting that causes people to be gay? I think a huge problem in those studies focusing on familial factors is that I think many of these studies, they focus upon, or they confuse correlation with causation. They confuse correlation with causation. And I like when I speak to Chinese audiences, because I think I don't have to explain as much on this, because, being scientists and engineers, we kind of understand correlation and causation. My Caucasian brothers, and sisters, sometimes I have to explain more. But, with correlation, causation, they're not the same thing. Causation, what is that? That's really easy to explain. Causation is one factor or a group of factors bring about another factor or a trait. Clearly cause and effect. Correlation is when there is some type of relationship between two factors. So when one variable maybe goes up, we find if the other variable goes up at the same time, we call that a positive correlation. When one variable goes up and the other one goes down, we call that a negative correlation. Or the other way around, when one variable goes down, the other one goes up, then we call that a negative correlation. So it's important to note that a correlation does not necessarily mean cause or effect. It could, but it could be indirect, meaning there could be a third variable that's influencing a third or more variables. Or it could be coincidence, meaning it was complete fluke, like it was just an accident. So, we need to also know that correlation that does not necessarily mean causation. It could, but not necessarily. So let me give you an illustration that can help illustrate the difference between correlation and causation. So in New York, it's been shown, researchers have looked at this, that when there's an increase in the consumption of ice cream in New York City, at the same time, there's also an increase in murder rates. Yeah? This has actually been shown by numerous researchers that when there's an increase in the consumption of ice cream, at the same time, there's also an increase in murder rates. So we think, when you see data like that, we think, wow, that's just crazy. We know, obviously, that's not cause. Eating ice cream does not cause people to kill one another. Depending on what flavor you're eating. But generally speaking, eating ice cream does not cause you to kill people. That's not a cause and effect. We don't even have to really research that. But it can't be coincidental. Why? Because this has been shown over and over and over again. That it is a fact that when there's an increase in consumption in New York City, at the same time there is an increase in murder rates. So it's not cause, it's not effect, it's not coincidence, so therefore it must be indirect, meaning that there's a third factor that's influencing the two, that's causing them to both go up. What would that be? Anyone guess? Summer. Heat. Warmth, right? So what happens during New York City during the summertime? People are wanting to eat ice cream more. So people are purchasing more ice cream, they're eating more ice cream. Well, what's also happening at the same time during the summer? People are killing each other. I don't know. Murder rates are going up. It's hotter. People are out on the streets more. Probably people are fighting more. More gangs are out on the street, gang banging. Tempers are more easy to flare. Murderers are coming out of hibernation. So all these different reasons that can play into the fact that at the same time, this is a perfect example of correlation. One variable, ice cream, another variable, murder. And we see at the same time both are going up. But it's not that one is causing the other, it's some other third factor that's influencing the two. And in research, as many of you guys know who do research, it is often hard to control all the variables, right? You want to do your best to try to isolate everything and put things into vacuum sealed environments and just to do that. But when you're doing sociological studies, it's almost impossible to control all variables, right? Almost, you want to do your best to control all variables as possible. And so how do you work against that? Well, to prove causation in sociological studies, in social science studies, it's much harder than in natural science studies. Because in natural science, we can really isolate things and to keep things when there's no other variables. So we have one group which has, and so when you have these two groups, maybe the only difference is just one variable or two variables. That's easier to do in a closed environment in the natural science research.